When variance is unknown, the choice of sample size is a little bit different, and that's what I'm going to cover in this screencast. When the variance is unknown, there is no easy way to calculate n using a simple formula as we did when the variance is known. In this case, we have to use the t-distribution based operating characteristic curves that are in the appendix. This is really the only way to estimate sample size. Let's go through an example. The weight of a Qdoba burrito is approximately normally distributed. A random sample of 5 burritos was made and the average burrito mass was found to be 692.7 and the sample standard deviation was found to be 16.2. Assume that the true variance is unknown. If it's important that we detect with 80% probability, that means beta equals 0.2, and the power of the test is 0.8, that the mean burrito weight has shifted 10 grams, what should be the sample size? And we're going to use an alpha of 0.05. We can do the same type of thing that we did for the variance known case using the operating characteristic curves. We can calculate this d value. That's the shift in mean. In this case, that's 10 grams. We want to be able to detect if the burrito weight has shifted 10 grams. And we divide by sigma. Now, we don't know that, so we use our sample standard deviation to estimate the population standard deviation. So in the denominator here, we have our sample standard deviation. And again, if variance is unknown, you can imagine there's going to be some error in this, but that's taken into account in these operating characteristic curves. So we get a d value of about 0.6. We can go in here. Here we have our operating characteristic curve for one-sided t-test. So we're doing a less than or greater than test. For a level of significance of alpha equals 0.05, d equals 0.6. Since power is 80%, that means beta is 0.2. And we can go in here and look at that, and we see that we need about 18 samples in order for us 80% of the time to successfully detect that the mean has shifted 10 grams or more. So hopefully you learned how to calculate sample size when the variance is unknown in this screencast.